Okay, now we're going to do 10-7. And guess what? We're going to talk about circles again. How about that? Amazing, isn't it? And we're actually going to have two secants that intersect inside the circle. So let's do that. Let's do two secants that intersect inside the circle. But we're not talking about angles this time. We're not even talking about arcs. We're actually going to talk about the line segments that are formed. You could say two chords or two secants, right? If you consider it a secant, you're just saying, okay, it just keeps on going, right? But we're talking about the line segments inside here. So let's just refer to them as the chords. This is pretty simple. I'm not really going to show you proof or anything on this, but, and I don't think they have it in the book. I looked in the book to see if they do have one, but they don't. So you got two chords. They call this the segments of chords theorem, okay? Brain, or it's not, what was I going to say? I don't know. I was going to say something. I don't know what I was going to say. All right, let's take a look at this. We'll call this little segment A. Is that all right? In the book, you put a capital. They, put points on all these points of intersection right here. But I think I'm going to call this little segment A. I'll call this little segment B. Everybody see what I'm talking about by A? A goes from here to here, and B goes from here to here. Then I'll call this one C, and I'll call this one D. Everybody with me? Now watch. You just have to believe me on this one. Again, I'm not going to do the proof for you or anything, but I'm sure there's a proof somewhere floating out there. If you're really concerned, you can always look it up on Google, right? Proof of this theorem. But let's just show you what it is. It's very, very simple. If I wanted to find, these are all lengths of segments. It's not angles, it's not chords or anything like that. It's just the length of a segment. Well, here's what's true about the relationship between these chords. Remember, these are chords in a circle. They don't have to intersect at the center or anything like that. They could, but they don't have to. Here it goes. It's really easy. If I took A times B, that's going to equal, what do you think? What do you hope it is anyway? C times D. Exactly, and that's exactly what it is. So if I multiply A times B, that's going to equal C times D. There it is, right there.
So does A equal C, or does A
No, not necessarily. No, doesn't mean that all these could be all four different lengths. Right, okay, but the product of A times B is going to equal the product of C times D. All right. So let's stick a number in there, and you kind of know what they're going to do, don't you? They'll probably give you like 3 of the segments and ask you to find the 4th one, wouldn't you think? So let's put some numbers in. I'm just looking at the example. Tell you what, let's do one a little more complicated. We won't do the easy one. I think you can handle this. We'll call this x plus 1. We'll call this x. Nope, I lied. Let's do this. I'm sorry. X plus 8. We'll call this x plus 1 because they drew theirs a little bit different than I drew mine. And then we'll call this x, and we'll call this x plus 10. Okay? That's supposed to be an x. I know I was a little sloppy with that. Everybody with me? So now, how in the world could you solve for x? And the question says to find x. Yep. Or they could ask you, right, they could put some letters here if they wanted to. And they could ask you what one of the segments were. They could say, we'll call this x. Nah, let's not call it x. Let's call it e. All right, they could say, what is AE, or what is AC, or what is BE, or what is BD, or whatever, okay? They could ask you all kinds of stuff. But the most important part is to solve for x here, isn't it? So how would you solve for x? With this little theorem that we know. Okay, so let's take these two and multiply them together. So it's x plus 8 times x plus 1. Now, what are you going to have to do? FOIL, right, okay. And you might get a quadratic. Well, let's see. Let's do the other one. What's that going to equal? What is the product of these two? X plus 10. Yep. Right, all you got to do is just distribute this one. You don't have to do it. Okay, so let's do this. We should be able to do this now, right? So it's x squared. Let's do this next part in our head, the outside and inside. It's plus 1x plus 8x, which is plus 9x. Everybody see that? And then the outside, or the last, I'm sorry, 8 times 1 is 8. Right? So you should be able to do that. You don't need that little secondary step in there, do you? You should be able to do that in your head. What about this one? What's that going to give you? X squared plus 10x. Now, luckily, this doesn't really come out as a quadratic because what happens to the x squareds? Yeah, they cancel out. Okay, I'm okay with you saying cancel out, but you subtract x squared from both sides, right? And, yep, that's fine. I don't mind you saying that. They cancel each other out. And now you just solve for x. Now it's easy. Subtract a 9x from both sides, and that gives you x equals 8. And there you go. And if you wanted to, you could plug it in and see if it works. Let's just see if it does work. This is, x is 8, right? So that's got to be 8, and what's that got to be? 18. Okay, this has to be what? 16, and this has to be 9. So let's see if that actually works. Who's got a calculator? So 16 times 9 should equal what? 18 times 8. 144? Do they both equal 144? Sure enough. Okay. It's pretty cool, isn't it? I probably won't have that on a test or a quiz. I don't know. They might. I mean, there's a possibility they could give you it as a quadratic. I mean, you'll have to either factor, and we're not going to go through that right now. Okay, that was an algebra topic. So, if we actually get in a problem where you have to do that, we'll hit it. But we're not gonna hit that right now. All right. So, what do you think? That's not too hard, is it?
That was in the lesson.
Well, it was part of the lesson. Okay, that was the easy part of the lesson. Yeah, the next part's really not hard. It's just different stuff is all it is. I don't think it's any more difficult than this. It's just a little bit different, that's all. All right, so the product of the segments are equal to each other on both those chords. Does that mean both the chords are equal to each other because the product equals each other? No, because look, this is 18 and 8. What's that whole BD? What is the entire BD? 18 and 8. It's 26, isn't it? All right, what is AC? It's 16 and 9. So AC is what? It's 25. They're not the same, are they? So it doesn't mean that the chords have to be equal to each other. Just because the products of the segments are equal to each other does not mean the actual length of the chords are equal to each other. Make sense? Okay. All right, let's do another one. Now, we had two chords that intersected inside the circle. Guess what? Or two secants, if you want to look at it, intersect inside the circle. What did we do in the last section? Two secants that intersect outside the circle. So let's do that. Let's draw our circle right here. And let's scooch it over a little bit. And let's do our two chords. Let's try a different color. Let's go blue. Okay. And watch. Here's a secant. And here's a secant. They intersect at a common point outside the circle. Okay, they intersect at that one point outside the circle. Now again, we're not talking about arcs, we're not talking about angles, we're talking about the lengths of segments. And so let's mark these segments. Let's mark that A. And what is the A? If I just put an A right there, what does that indicate? From the point where? To where it hits a circle. Okay, right there. That segment right there is A. And this one would be B. Is that all right? Thinking whether to mark this or not. All right, I'll mark that C and D. Okay, now here's what the thing says. All right, the theorem. I don't know, does this one have a name to it? The secant segments theorem. How about that? And I don't remember what it is, but I just remember what it says. Okay, so what this says is, and I'll give you a little bit of a shortcut way to remember it, but we'll put all the letters in. So this one says that if I take the outside segment, do you see how this whole secant right there, we'll call it the whole secant, even though a secant is a line. We'll talk about that. We'll just say from here to here, okay? This whole entire thing, if I take the outside segment and multiply it by the whole entire secant, follow me? So what's the outside part of this secant? It's A. What's the whole entire secant? It's not A times C, it's A plus C. So watch. If I take the outside and I multiply it by the whole thing, and that's how I'm going to refer to it. I'm going to say it like that all the time. I'm going to say the outside times the whole thing. And the whole thing is A plus C, isn't it? That's going to equal the same thing on the other secant. So what's the outside of the other secant? B times the whole thing. What's the whole thing on the other secant? B plus D. Follow me on that? Okay. So really, I like to say this. I like to say the outside times the whole thing equals what? The outside times the whole thing of the other one. Make sense? So if I take the outside segment, which is this, and I multiply it by the whole entire segment, the whole entire secant, if you want to call it that, all right, and that's going to equal the same thing on the other side, the outside times the whole thing. Let's put some numbers in. Let's do a quick little example. And we got one more to do after this, but it's really, really close to this. You want one that's a little bit trickier? Yeah, let's do this. Let's call, this may not be drawn to scale, but it doesn't make any difference. Call that, we'll call this 10, we'll call this 6. All right, there you go. And we want to find what x is equal to. Right, got that? So what are you going to do? You can take the outside, which, let's do this top one first. What's the outside of that top one? It's 8. And multiply by the whole thing. What's the whole thing? Right, let's go x plus 8. And that's going to equal the same thing on this other one. So it's going to be what? The outside part, which is 6, times the whole thing. What's this whole thing? 16. Yeah, I didn't have to put 10 plus 6, did I? Just add them up. You with me on this? And now you just solve for x. It's easy as that. So that's 8x plus 64 equals, what's that, 96? Is that right? It's a 3. 6 times 16? Isn't that 96? Yeah, it is, isn't it? Sure. All right. Guys were pausing, so I was doubting myself. And then subtract the 64, divide by 8, and you get 4. So I'll just do that. X equals 4. There you go. Does that mean these two secants are equal to each other? No, because if this is 4, what's this whole entire secant right there? It's 12, and this is 16. So you can see they're not exactly the same lengths. It's not too hard, is it? So what do you remember, though? Remember, you take the outside part times the whole thing, and that equals the outside times the whole thing of the other one. I think that's an easy way to remember it. Don't you? All right, we've got another kind. And this is it, after we do this one. So guess what we're going to do now? We're kind of following the same pattern we did before. We had two secants that intersect inside the circle. We talked about two secants that intersected outside the circle on the last section and this section. And then we also talked about what? A secant and a tangent. So let's do that. Let's do a secant and a tangent. So here's the tangent right there. Let's make this a different color, blue. And I'll tell you what I'm going to do. I'm going to take this tangent, and I'm just going to draw it up to the point of tangency. Is that all right? Because all the part after that is not really going to count anyway. So that's a tangent. Everybody okay with that? And that's the point of tangency right there. And I'm going to draw a secant. I'm not just going to draw a secant anywhere. Guess where I'm going to draw the secant? From this outside point, okay? So they're all going to come to the outside point. This is very, very, very close to what we just finished doing. And let's put some different letters in here. We'll call that A, we'll call that B, and we'll call that C. You could, I bet you, some of you could probably just guess and get the formula for this. Let's start off the secant the same way as we did before. How would we start that secant off? A, take the outside times the whole thing. What's the whole thing? A plus B. Everybody see that? Take the outside times the whole entire thing. What do you think that's going to equal here? Very good. Why c squared? Because you looked in the book and saw it. Remember, this is the outside times the whole thing. Well, look, what's the outside part of this? The c. What's the whole thing of this? It's c. So what's c times c? C squared. Does that make sense? So it's kind of like the other one, isn't it? It's kind of like they're two secants. We take the outside times the whole thing. Well, the outside is the whole thing. So we multiply them together. C times c is what? C squared. Make sense? It's not hard, is it? Let's stick a couple numbers in here just to do a little example, a little practice with this. And here we go. Oh, on this one, hey, you wanted a quadratic? You got it. This is 8. Savannah, you look disappointed that we're going to do a quadratic.
I'm already having a bad day.
Well, the quadratic equation should brighten up your day. All right, here we go. This is in the book, yes. Let's take a look. So what are we going to do? We're going to take, let's start up here. Take the outside times the whole thing. What's the whole thing? X plus 7. And that equals what? The other one squared, so 8 squared. So let's do that. We got x squared plus 7x. What's that going to be? 64. But watch, now we realize it's a quadratic. Our x squares don't cancel out like they did on that other one. So we're going to put minus 64 equals 0. All right. I don't think this factors. Is there anything that multiplies to be negative 64 and adds up to be 7? Don't think it does, okay? So you try a whole bunch of stuff and nothing works. So what can you always rely on? The quadratic formula, right? And we've talked about the quadratic formula. Hey, you better like it because next year in Algebra 2, you're going to be doing it a lot. Let's do it. It's not that hard. You don't whine, all right? No whining allowed in here. No whining allowed. Because this is not hard at all. It's actually pretty easy. It's all set up for you. Just plug it in. Exactly right. You just plug stuff in. So what are you plugging in? What's the b? It's 7. So it's going to be equals negative 7, right? Plus or minus. This is not hard at all. B squared. Well, we said b was 7 already. Square it. It's 49. Minus 4 times a times c. What is the a over here? The a is the 1. All right, and what's the c? It's negative 64, right. This is a, this is b, and this is c. That's all you do. It's just plug and chug, right? Over 2 times a. Yep. 2 times a. 2 times 1, which is just 2. And now, and that wasn't hard at all, was it? Plugging stuff in. This is the hardest part of it, is just figuring this out. But you got a calculator. It's not that big of a deal. So what do you get? So it's going to be 49 plus whatever 64 times 4 is. Let's do that. What's 64 times 4? It's that plus 49, right? I'll show you. And that's 305. 30. Why is it plus? Because negative times negative is positive, right? And that's why it's plus. And that thing is over 2. And to tell you the truth, as far as I'm concerned, you can just leave it like that, or you could plug it into a calculator. If you plugged it into a calculator, you actually get 2 answers, don't you? Because you got a plus and a minus. You would put negative 7 plus all this over 2. Then you go negative 7 minus square root of 305 over 2. So you get 2 answers. I'll just write them out due to time. So you get that or that. But what are we trying to do? We're trying to solve for x, aren't we? X is what? It's a length. It's a length. Can it be both of them? It can't be both of them, so how do we know which one it's going to be? Which one? Let's not even do that. Let's just look at your answers right here. The not negative one, right? Or the positive one, right? Okay, the one that's positive, because you can't have a negative line segment, can you? A negative length to a line segment. So you're not going to use that. So even though your math came out to that, in Algebra 2, when you do this in Algebra 2, that's going to be one of your answers. But in geometry, when you're actually finding the length of a line segment, you're not going to use the negative one. You just use the positive one. So x is equal to 5.2. Because it's 7 squared. Because it's b squared. Because it was minus minus. And a minus minus is a plus, so I made them plus.
And you would have to do the 49 plus, and then you have to find what's.
And then you take the square root of it. Yeah, 64 times 4, we already did that.
You have to do that.
250. I mean, I did. You don't have to, but yeah, I went 64 times 4, just added to the 49, which is 305. Then, how do I do this on the calculator? Just take the square root of 305, add it to a negative 7, divide that whole thing by 2, and you get this. Negative 7 minus that, divided by 2, and you get this. Pick the positive one, and you're done. All right? So that's not bad, is it? Yeah, quadratics aren't too bad. Now, there's a couple ways you're going to solve it in Algebra 2. 3 ways, actually. There's going to be factoring, but this one you couldn't factor. But you can also do this thing called completing the square, right? Which is a good way to do it. All right, let me write your homework down. It's actually Wednesday night's homework because, yeah, let me just pass it and put it in the front row. Actually, just put it on the table up here before you go. I'm getting there. It's page 740, and we're doing 6 to 21. 6 to 21, and that's section 10.7. All right, 6 to 21. Put your homework right up there on the table. Just make a pile. and I'll get them from you.